Ladies and gentlemen, today we're going to learn about how to build stacks using JavaScript. Let's say if you're a JavaScript developer and you are giving an interview, and during an interview you have to solve a specific problem using a specific data structure that is not native to JavaScript. You're going to have a difficult time because even though you know how to solve the problem, you probably have to build that data structure in JavaScript, and that's where the problem comes from. So it's good to know how to build specific data structures in JavaScript. So let's start with an easy data structure, stack. So today in this video, we're going to understand what is stack quickly, and then we're going to build stack using JavaScript with all the methods. And then we're going to look at the complexity of each method. So let's say if you have a method for searching, what is the complexity of it? Because you may get an interview question where you have to explain that and why you're using stack, so which is very important. And in the end, we're going to look at some of the interview questions that you can potentially solve using stacks. And welcome to Texi Tutorials. So before we build stack, let's just quickly look at a physical example of what a stack is. Stack is nothing but a pile. Here I have an example of Legos, a pile of Legos. You can only put things on the top. So here, if I want to add something, I can only do it on the top. I cannot do it in the bottom. Also, I cannot remove things from the bottom, right? I can only remove this green here, only this item. I cannot remove this guy, or this guy. And that's in a nutshell what stack is. You can put things on the top and you can remove things on the top. That's it. It's also called LIFO, last in, first out. Because if this was the last item that was put on the stack, this is the first item that can go out, right? Because you cannot remove this guy, or this guy. Same way you can say first in, last out. The first item that was put in this tag was this red block, and once I remove everything else, then I can get this out. So it's LIFO and FILO. So let's look at a simple example. If you think of a stack, instead of like a vertical stack, we can look at a horizontal stack. Think of this as an array. This is the beginning of the array, and it has 3 elements, and I want to add, let's say, another thing. I can only add it at the end here, right? And if I want to remove something, I can remove from the end. So let's say if I want to add another item, I can push this on here and it would be 100, and I can remove this 100 using pop. And then I'll get the original array. Let's look at some of the methods that we can implement for stack. So as we looked at the push method, where if you want to insert something, an item to a stack, basically putting a new item on the top of stack. Pop would be removing the last item that you put on the stack. Peek would be peeking into the last item, which means you want to look at the last item without removing it. So in case if you run peek, it would give you this green Lego because this is the last item. Length would give you the length of this stack. In this case, it would be 1, 2, 3, 4. You can say is empty to see if something is empty. If the stack is empty, you can search also, or you can empty the stack, which means remove every single item from the stack. Okay, so let's build this in JavaScript. Okay, so in order to build a stack, there are multiple ways to do it. One is you can use classes, or you can use functional programming. You can also use prototype methods with functional programming. But I'm going to just use functional programming and closures, which is kind of latest trends because everything is kind of functional nowadays. So let's do that. So first we're going to have a function that creates a stack. So I can have a function called, let's call it a capital create and stack, and this will have one argument, which would be maximum size. So I can provide a size of the stack. For example, if you heard the word stack overflow, which means whenever your stack wants to grow beyond the maximum size, it will give this error called Stack Overflow. So here, if nobody provides this, I can have a default parameter. Let's keep it 10. I know it's very small, but for sake of doing it. Inside, I would need two variables. One is something to hold all the data. For that, I can use an array. Now, array is the simplest way to hold this. You can use object as well. But for stack, I would use arrays because it's the easiest way. Also, I would use some sort of a counter that holds the size of the stack. In this case, I'm going to call it top equal to -1. So right now, there are no elements, right? If you look at the array, arrays have index start from 0. So if I add first item in this stack, this would be more like an index. This would increment to 0, right? Because right now it's -1. So if it's empty, it's -1. If it has any items, it would be 0 or higher, right? So this way I can keep track of it. Let's have our first method called push. So I can have a function called push. And push would be just pushing a value into a stack. In this case, we're going to have a variable called val. And normally you would simply do this. I already know what a stack is. So I can say stack dot push val, right? It's very simple. And then I would have to increment top by 1, right? However, I would also need to make sure that it doesn't exceed my maximum size, which is this size, right? So I would first check before I insert it. So I would say if my top, which is the size in a way, it's greater than equal to the max size -1. If it's greater, then I can say return, let's stack overflow, right? Else, let's have a function called print that would allow you to see inside the stack. It would just basically print the whole thing out. And all I have to do is console log stack, and I can just toString it, which means it will just convert into comma separated string, right? Okay, so I have a function called create stack, and it has two functions, inner functions, push and print. If I want to access it, I will have to return them as an object. So I can say return two things. I would return the push and print. Okay, so now let's build our first stack using this function. And I will insert all other methods later on, but let's test it out first. Let's do it. Const new stack, or let's call it my stack. It's more personal as this, and I'm gonna provide a size, let's say 1000. And then I can say my stack dot push. Just gonna push 0 in here first, and I can also, let's say my stack dot push 1, and then I can say my print. Okay, hopefully I haven't made any mistakes, and I can run this. I can see 0 1. Again, this is not an array. I created, basically converted into a string so I can see it easily. So I have two items. The last item is 1. Okay, so now we know that works. Now let's add more methods. The next logical method would be pop, since we have already push. Pop doesn't have an argument. You just simply remove the last item from the stack. But we also want to check if it's an empty stack, there's nothing to pop out, right? So we can say if our top, remember empty means -1. So we can say if it's greater than -1, which means there are items in the stack, then what we want to do is let's get the last item, so top item in that sense, right? So we can say last equal to stack and top, right? This would give us the last item. Then we would reduce the size of top by 1 because we are popping it out, and we would return the last item, because pop not only removes the last item, but it also reduces the size of it. And actually we have to also do pop. Pop is a native method of an array. Else, if there is nothing to pop, then we don't do anything. You can return something like null or something. Let's try this out, but before we would need to return this pop. And then here, after to push, we can do pop. My stack dot pop. And this time if I run this, because I've inserted 1, 0, 1, and remove the 1 because it takes from the top, right? So it should be only 0. And when I run it, I would see 0. Okay, so next method would be size. I want to get the size of the stack, right? So that will be very simple. Or you can call it a length, doesn't matter. This would simply return whatever the top is plus 1. If it has nothing inside, which means top is -1, then the size would be 0. Let's say if we implement peak, which would give you the last item without removing it. So I'm going to say function, this would simply return it. It doesn't modify the stack, right? I would have to check first if it's not empty. The top is greater than -1, which means not empty. Return the stack's last item, which is the top. Else, return null. So let's do a peek. But for that, we would have to also return those methods here. So size and peek that I've added. So first would be size and the second would be peek. Let's look at the peek here. My stack dot peek. Let's remove pop from here. So the peek would give us 1, which is a new value. Now I would have to console log it first. Otherwise it's printing this line. Okay, so it gives me peek, which is 1 here. Now the more difficult method would be search. Let's say if I want to find a value inside the stack. So far we are dealing with the only top part, which is either we are looking at something on the top, removing something from the top, or adding something on the top. What if we want to find a value inside a stack? So for that, we would have to have a function called search. And we are going to search for a value, right? So I can say find 1 inside the stack. I would have to remove all the items from the stack one by one and compare if it's matching the value, right? Remember, in stack, you can only access the top item, which means if my value is not the top item, I would have to remove it so I can access the second item from the stack, right? So I would need an extra array for that. So I'll say let's const temp equal to an extra array, and also have a variable called found equal to null. Then I would need to have a while loop, remove until I reach the end. The top is greater than -1, which means there are some elements left. The stack top item is equal to the val, which is the item there that we are trying to look for. If it matches, then it's good. We can say found equal to the top, and then we can break this. But if it's not, then we'll just keep going. And then for each item, what I want to do is remove from the top and then put it in this temp. So I would say temp dot push the stacks dot pop, because we already have a pop method that removes the top item, and we push that into the temp, and then we would do -. So essentially this is removing each item one by one from the top, comparing against the value that we are searching for, and then if it finds, then it stops. Otherwise it keeps pushing each removed item into the temp. So let's say if we don't find it, then all the items that were in the stack would be in temp, at the end of it. So now what we want to do, once it's done, either we find it or we don't find it. Then we want to put all the item back from temp to the stack, right? So let's have a length, temp length equal to the temp array. And then we would do we can simply use a for loop, let I equal to 0 to I less than temp length I plus plus, and we would simply take every single item and push it back into the stack. So stack dot push and temp dot pop, and at the end we would return what have we found. Let's say if we found nothing, then it would be null, right? Because we initialize as null. Otherwise, it would return whatever we found. Try to find it. So instead of peek, we're gonna say search. I'm gonna search for 1. Oh, I would need to also return it so that it's available. I would get 1, which is the index of that, right? So instead of 0 and 1, I can say hi and hello. And if I look for, let's say, hello, then it should give me, let's just remove this print for now. It should give me 1, right? So it gives me the index where it finds this hello. Okay, so the next method would be, which is the last method, is empty. I want to completely empty the stack, which is pretty simple actually. Let's say function empty. This will be simple. We can simply do while loop, and if top is greater than -1, then keep popping items from stack, right? And also decrement top every time you pop it out. And that's what you have to do. Remove this, and I can say my stack dot, and then let's try to print it and see what it comes back with. Return this. Otherwise it would give you an error. Okay, it will return an empty array, empty string, which means there are no items in the stack. So this is how to implement stack, and I'll provide a link to this document in the video description so you can try it out. Let's look at the complexity of each operation. Let's start from, so push would be O of 1, also would be O of 1, because we remove it right away from the top because we don't have to go too deep, right? The size, that would be also O of 1, because remember, we are keeping track of the size, the top, right? What about peak? That would be also O of 1, because we're only looking at the top element, so we don't have to go through the every item in the stack, right? Okay, what about search? So search is the only item that is a little bit complex, because to find it, I would have to iterate through every single element of the stack. And actually twice, because I have to remove once and then I have to insert back. So this would be O of n. That's the size of the stack, right? Empty also, I would have to do the same thing. I would have to remove every element one by one. So I would call it O of n. So now let's look at the application and what kind of problems you can solve using stack. So first of all, if somebody asks you, what is a practical application of stack? So you can point them that, when you run JavaScript, when you execute JavaScript, all the functions inside JavaScript gets pushed on the stack and gets executed from there, right? So browsers has an execution stack. So practical application. You can reverse a string using stack. You can check if a parenthesis is valid inside a string. So basically you can do syntax parsing as well. And there are lots of other problems you can solve with stack. But as you can see, that stack is a very simple but very useful data structure. And lastly, if you are in an interview and if you want to use stack and you don't want to build, let's say, all of these functionalities, then instead of building all of this, you could tell the interviewer that I'm just going to use JavaScript arrays, because JavaScript arrays have a method called push. It has a method called pop. It doesn't have an empty or search. Search you can use is an index of to find some item inside the stack. But make sure that you don't remove anything from the middle of the array or beginning of the array, right? Only you can insert at the end of it or remove from the end. So that is a restriction, and but you have to communicate that to the interviewer. I hope you learned something new from this video, and if you did, please like, subscribe, and provide a nice comment on the video. You can follow me. I have multiple interesting Facebook groups. One of them is algorithm and data structure. I'll provide all the links in the description so you can easily copy paste it. But I have a couple of groups that you can follow. You can follow me on Twitter, and also have a Medium articles, so you can check that out. I have a couple of courses, one on React and one on JavaScript. You can check it out, and thank you.